minutes to enhance, whatever your goal is in terms of mathematics, which I believe is an upcoming exam. All right. All right. So I had some documents up and I lost them, but luckily I found them again. All right. So what we're going to do today is just some random questions, and I'm going to share my screen in a moment. All right. So basically, all right. So I'm gonna share my screen. All right. So all right. Are you guys seeing this question here?
Yes, sir.
All right. I want you guys to give that a try. And you know that whenever we are doing these questions, we find the LCM. But spend a minute and just get a go at a look at it. Okay, I'm trying to figure out why this thing is. All right, so if you're just joining us, I am asking everyone to attempt this question. It's an algebraic fraction question. All right. So I hope you're like 80% through. So while you're 80% through the activity, I will proceed. All right. And after which I'll give you one to try on your own. So clearly the LCM here is what? It's 15, right?
15.
Right. And we're going to say 5 into 15 goes what? 3 times. And it's going to be 3 times all of this. But what we do, we write it down here. So 2x plus 3. Subtract 3 into 15 goes what? 5. So it's going to be 5 times all of this. So 5 times x plus 2. All right. And then we're going to use the distributive law or the distributive property and multiply 3 times everything on the outside. So that's going to be 3 times 2x, which is what? 6x. 3 3 is 9. And 5 times x is 5x. All right. And negative times a positive will give us a negative. So 5 twos is 10. All right. So some persons, we might just drop down the plus sign, but that's not what we're doing. All right. We use the rules of multiplication for this thing here. And then we put all that over 15. All right. I think somebody needs to mute the mic. Now, what we're going to do next now is to group like terms. So as you can see, 6x and 9, they're unlike. But you can actually group 6x and what? 5x. And you can group the 9 and the negative 10. So I'm going to group the like terms together. Notice there's no change in their sign. All right, so it's plus 9 minus 10 all over what? 15. All right, and then we just proceed to compute the like terms. So 5x from 6x is 1x. I'm gonna put the answer up at the top here, if you don't mind. It's going to be 1x or x, and 10 from 9 is negative 1 all over 15. And that's the answer. All right. Any questions about this? And can I say 1 from 1x? No, you can't. Say leave it like that. All right. Anybody writing this off? All right. So I'm gonna take it down.
Sir.
Yes. Oops, I pressed X a while ago, but it's not loading. So if it talk quick.
Yes, sir. I was asking about the negative 10 there, sir.
Okay. Oops. You know, say it gone a while ago. Jody, really sorry about that here. I should have pressed but I pressed no a while ago. I don't know what happened. Okay, I lost that here, Jody.
Okay.
Sorry about that. The question is still here, but I just lost the solutions a while ago. I actually pressed X on it a long time, but it wasn't loading. So you know. All right.
Sir, so I answer, sir. I never get to write off that.
Oh dear. You know what? Let me go back again. Where did I put the question? Is this right? All right, my computer is running really slow. All right, so we said that we find the what? The LCM 15. 5 into 15 goes 3. And 3 times what? 2x plus 3. 315 goes 5, so it's going to be 5 times x plus 2. And then we'll just use the distributive law. So 3 times 2x is 6x. 3 3s is 9. A negative and a positive gives you a negative. 5 times x is 5x. All right. Now some people think that, boy, sir, see plus there, see the negative there, and you just drop it back. But no, that's not what I'm doing. That's not what we're doing. We're actually using the rules of what? Multiplication. All right. So we're not dropping down any signs. So right here, so a negative and a positive will give you a what? Negative. All right, Jody? And that will give us 10. 5 2 is 10. What will happen if this plus was a minus? You'll get negative and negative to give you what? A positive right there, not true? Right. And then now we're going to group. Jody, are you following now?
Yes, sir. Yes,
Right,
sir.
right. We use the rules of multiplications. So we're going to group like terms. So it's going to be 6x subtract 5x.
So, sir,
Yes, plus 9.
so when you move like a negative sign on them somebody, like how you know which one I sign them for move? Like which side the sign supposed to be on? The left side or right side when you group it? Like if you take it if you take a sign with it.
You're talking about this part here?
Yeah, man, like me I talk about the plus sign and the negative sign, like how you know which sign to take on group.
All right. Okay. So it's a case where you're gonna group like terms. So for example, this is 6x, right? And this is negative. This is 5x. But the 5x, is any sign that is in front of the term, it belongs to it. So if I'm gonna move, root up this 5x and put it beside that 6x, whatever sign is with the 5x goes with it. So the negative goes with it, basically. All right. If you notice that if you're to check on the right hand side, all the signs are the same. Look, that's negative 10. That is also what? Negative 10. That is what? Negative 5x. We also have what? Negative 5x. This is what? Plus 9. So that's also what? Plus 9. We have plus 6x. And that is also what? Plus 6x. So everything remains the same when we group, or should remain the same. So in other words, what I'm saying is, if 10 is negative, and you shuffle it around, 10 can automatically become positive because we just group in terms. All right. Does that answer your question? Or you still not clear? Or you want some more clarification?
Yeah, man, I understand now.
Yeah, man. All right, cool. So I think I know why you ask me, because sometimes, for example, suppose you have let us say 5x minus 3 equal 2x plus 6, right? Suppose you have something like this, and you're asked to solve this. And I know some of you teachers might say, boy, the sign can change, So this plus 2x becomes what? Minus 2x. So, and then this minus 3 becomes plus 3 and all them something there. And you find that sometimes the sign will change. All right? But we're not doing that. There's no equal sign in the question, in the question at hand. So the sign won't change, all right? Okay. Any questions? All right. All right. Can I take? Oh, I didn't get to finish the answer. All right. So 5x from 6x is just 1x, or 1. 9 subtract 10 is negative 1 all over 15. All right, and as you can see, you can't subtract those two because they're unlike. All right. If I had an x right here, so then we could what? Subtract it, right? Or we have some numbers right here. All right, can I take this off, class? Is anybody writing?
Finish right, man.
All right, cool. Very, very good, very good. I'm just gonna take you to somewhere else. All right. Look at number 6. Look at this question here. This is something similar that we did a while ago, don't you? But can someone tell me the difference between this question and the one we did a while ago? What's the difference?
Sorry, I have an equal one.
Right, we have an equal sign, so this becomes a fractional equation. So prior to that, we that was a fractional what expression, but because they input an equal sign, it becomes an equation. All right. Now there are two ways to approach this question. I'm going to show you one of the ways. All right. Now, one of the ways you can use is to draw the line and do the same thing that I did a while ago. But I don't like that method when solving fractional equations. All right. So this is what you're going to do, or this is what I'm suggesting that you do whenever you're solving fractional equations. All right. So what we're going to do, the first thing is that we're going to bracket each term. So the instruction was said to solve, but the question we did before would have said to what? To simplify. Solve for P. So we bracket each term, and what we do is that we find the LCM. And the LCM of 2, 3, and 1 is, as you can tell, it would have been what? 6, right? Right. So then now, when you find the LCM, what you're going to do, you're going to multiply each bracket by the LCM. Everybody see that? Let me explain again. What we do, we bracket each term, find the LCM, then multiply each bracket by its LCM. And then now, we're going to cancel. 2 into 2 goes 1. 2 into 6 goes 3. 3 into 3 goes 1. 3 into 6 goes 2. And 1 into 6 will give you back 6. So you don't have to work out that one. Now, what do you know about all the denominators, class?
They are one.
Right.
Yeah,
all of them are right. All of them are equal to 1. And you can actually ignore the 1. All right. So it's just like 5 over 1 is same thing as what? Same thing as 5. Am I right? Yes. 7 over 1 is basically what? 7. All right. So what we're going to do is that we're not going to write the bottom piece here. So we're going to ignore the bottom piece. All right. So what we have here now is 3 at the top. 3. bracket p minus 1. So it's this 3 here, right? So it's this 3 times the top piece. Subtract, that's this subtract here. Oops. Subtract what? 2, which is this 2 here. Open bracket p subtract 2 equals what, class? What am I going to write out here, sir?
6, sir.
6.
6 multiplied by 1. All right. Okay. Then now we're going to use the distributive property. 3 times p is, talk to me.
3p.
3p.
Right.
3p.
What's 3 times 1?
3.
3. All right. No, guys, do you notice that I didn't use the rules of multiplication because, I mean, 3 times p is just 3p. 3 times negative 1 is what? Negative 3. All right. So 2 times p is going to be what? 2p. All right. So, or you could read this way: negative and a positive give a negative. What sign comes after the 2p and why?
Sir, it's going to be a plus 2, sir. Plus 4.
Plus 4, right? Because negative and negative positive. 2 2s is 4. Everything equals to 6. Is everybody clear? Any questions? Is there any line that you're not following?
That long, that you're on a short away for that, sir. Got on the long, you know.
All right. Are you following?
Yeah, man.
All right. Sometimes when the instructor is explaining and when you're attempting it, it's two different things, not true? All right. But to get full marks, I suggest you follow all these steps. All right, then now we're gonna solve this, right? So watch out now. We're gonna what? Group like terms, right? So 3p and 2p will go together. So 3p. All right, and this subtraction sign, it came from this 2p. And then we notice we have negative 3 and positive 4 equals 6. All right, class, can you tell me what is this? What is negative 3 plus 4?
Negative 1, sir.
You sure?
One, not just one.
Yeah, it's gonna be 1.
Yeah.
Because right,
Yes.
because the
Yes, sir.
right. All right, what is 2p from 3p?
1p.
1p.
P.
Or p, not true. And we said negative 3 plus 4 is positive 1 equals 6. All right. So you write back this 6. And then we'll just solve this equation. All right. Yet again, I need some space at the top here. Yet again, p or 1p plus 1 equals 6. So we'll just subtract 1 from the left and 1 from the right. So therefore, p is equal to 5. Let me give you a minute to take that off.
Repeat back the last two final step, no sir.
Hmm?
Can I explain the two final step? Just to make P turn 5.
All right. So basically, you want P, right? So basically you subtract 1 from both sides. So
Yeah man, me follow.
all right. Okay, so tell me when you're through so I can move on. It's
Sir,
important.
I'm finished writing.
You finish writing. Okay, very good. Anybody else writing?
Finish, sir.
All right. Okay. I want you guys to try question 16. All right, try question 16.
Sir, I've seen this.
You see it now? All right. Try
Yes, sir.
question 16. 4 minutes, maximum 4 minutes. And you're supposed to get the correct answer. Nobody reach halfway and stuck on part of the answer. You just need to get the full answer, all right? Just try aim for the full answer. All right. Do you need more time?
You look more time now.
All right. I'm going to give you a minute more or two.
All right, sir.
Okay.
Guys, please remember to click on the link in the chat section and complete the register for me, please. Only 6 persons have done so far. So just do that before the class ends, all right? Thanks.
All right. Okay, Mr. Green. Yes, class. Let me encourage you to register. All right. All right. Do I have a volunteer or volunteers? Who want to take on this one?
May try, man. May try.
All right. What's your
We
name?
on with Jeremy Grant.
Okay, Grant.
So suppose we put them in a bracket, right? Put it in a bracket.
Find the LCM.
Right. Fine. Grant, are you there?
Yeah.
Are you gone?
Yeah. Which is 8. 8. Lowest common multiplier 8.
You sure?
On a 8.
No, man.
Sir, 4.
It's 4.
John,
All right.
Jaja, my bad.
All right. It's a common thing to just multiply the two numbers and say, boy, LCM.
Yeah, man. Me just see it, man.
Yeah, man. John, John. All right. So the LCM is what? 4, and what you do next? You multiply each bracket by what? The LCM, which is 4. To be frank with you, Grant, if you use 8 and you work it out, you're supposed to end up with the same answer. All right?
The same answer?
Yeah, man, you're supposed to end up with the correct answer. The same answer.
All right. So the same.
Yeah. All right. So because he had used 8, somebody want to take it on? Or you want to continue, Grant, with all 4?
Would have to work it out and just pitch in, man. I work it out first.
All right, no problem. Anybody want to jump in and continue? Because he had used 8. All right. No response? Anybody?
So you're going to say 2 into 2 go 1 time and 2 into 4 go 2 time. 4 into 4 go 1 time. And then just 4.
Yeah, the last one is just 4, right? And then what next?
Sir, me not do it with the 4, but just tell you. So you're going to say 2.
Oh, you use 8 too?
Yes, sir. So you're going to put 2 and subtract 3.
All right.
Or minus sign and 1 and in bracket x plus 4 equal 1. No, equal 4.
4 times 1. Well, 4 times 1. I'm just going to put 4 bracket 1 because, All right. Okay.
So you have 2 times 2x, you give you 4x. Subtract negative 6. And then 1 times 1x, you gotta say have x, or I can put it 1x.
What sign goes right here?
Negative.
1 negative. Why?
When I multiply a positive with a negative it on.
Right. Very good. Very good. In other words, don't say you drop down this sign and put it right there, sir. Don't do that. All right. That's not the reason. The reason why we got a negative here is because we're going to use the rules of multiplication. All right. So a negative and a positive. By the way, no, we use the rules of multiplication right here, so because look, a positive and a positive give you a positive, not true? A positive and a negative gives you a what? A negative. Negative and a positive gives you a negative. All right. And what sign goes right here, sir? It will have to be a negative. Why? Because a negative times a positive gives you a negative. And what's 1 times 4? 4. And 4 ones is also 4. All right? Any questions? All right. Anybody want to take it from here? What's the next step? Starts with G. What does G mean?
So you're going to
Line grouping.
Right.
group the like terms.
Right. Jody, you want to take it up from here?
Okay, sir. Okay, sir. So
Yeah,
now, so you're going to say 4x.
Mm-hmm.
4x minus 1x or x.
All right, hold on. Question. The minus 1x, right? That you're saying. Is it this minus I'm using?
No, sir. The
Thank you
negative
very much.
sign
Right.
beside it.
It's a 1 right here, so not true? Very good.
Yes,
Very
sir.
good. And I want you guys to pick up on that. All right? Okay.
Then you're going to have negative 6, negative 4
Mm-hmm.
equal 4.
All right. Good. Thank you so much. Anybody want to jump in?
So I go subtract. That's what I gotta say.
Mm-hmm.
Yes, I go subtract negative 1 from positive 4. That I get 3x.
All right. Or you could just simply say 1 from 4x. All right. What about this one over here, sir?
2.
So you're going to have 10.
2.
Negative 10.
Negative and a negative make a positive, right?
Sir, 10.
10.
Negative 10.
Be negative 10
Yeah.
Negative 10.
equal 4. All right. All right. So, Mr. Grant, let me tell you how you this is all right. You see, if we were multiplying the two numbers, then you'll get a positive, right? But we're not multiplying. We're just subtracting two negatives. All right. So I never seem to have space ever. So what do I do next now? With this down here.
So you're going to add 10 on the right and 10 on the left.
10 on the left. Very good. Because of space, you see. I'm just gonna jump it right here. So you add 10. By the way, Jody, why are we adding 10? To the left and right.
Because it's the rule of to find the equation.
Right.
So whatever you do on the right, you do it on the left.
Yes, but why 10? Why not 4? Why not add 4 to the left and 4 to the right?
Sir, because we want to find what is x. Well, we're trying to find what is x. So we're trying to get rid of the 10 on that side.
Right. Very good. Yeah, right. So you see this negative 10 here? To get rid of it, we add 10. Because negative 10 plus 10 will give you 0. So all of this is going to go away. But if you add 10 to the left, you have to add 10 to the right. So we end up with what? 3x equals 14. And then what we do next now, class?
You have to divide.
So you divide by...
Divide both sides by 3.
By 3.
Right. Can you tell me what is this? This is in mixed fraction?
So well, I put it to decimal point.
I know I love fractions, right? So what is this as a mixed fraction? How many groups
4.
of 3? Mm-hmm.
4 2 over 3.
4 and
4
2
2
over
over
3.
3. 4 2 over
Right.
3.
Yeah, man. Very good. All right. All right. So thank you for your participation. Well done, all of you, except the LCM thing there. By the way, did you Grant? Did you get 4? Did you get 14 over 3 when you use 8? Or you get
Sir,
28 over 6?
28. Sir, I got 28.
We never reach that far, man. We never reach that far, sir. We really get
28 over
final.
6.
Okay, but guess what? Guess what? If you reduce
Sir, I
28
didn't
over
change
6.
it from improper fraction.
Okay, but if you know, if you reduce the 20 over 6, you'll end up with the what? The
Sir,
14 over 3. That's
4,
true.
I got 4.6 for the
Oh.
answer. Sir.
Okay.
Yeah,
See,
yeah.
you get the same thing, man. Because 2 into 6 goes 3. 2 into that goes 14. All right. But this is the answer. You can have the fraction. Let me tell you, if you write 14 over 3, mixed fraction or decimal, all right, anyone would work. Unless they specify. All right. Suppose answer to solve x correct to the nearest 2 decimal place. Then you'll have to work it specific to a decimal. Or if they say give your answer in the simplest fraction. All right. All right. Any questions? Anybody writing? Can I take this off? All right.
Yes, sir.
All right. So, all right. I'm gonna move to something that I don't know if you guys have learned this, but I'm saying, you know what? Let me try something. Let me experiment. Let me see if we can learn something. Let me see if we can learn something new. All right. You see my screen, right?
Yes, sir.
All right. So this topic here comes under relations, functions, and graphs. All right. I know some of you might not done this, but is there anybody who have probably touched on this topic before? Have you guys ever seen this before? F4 and GF4 and all them something?
Yeah.
No, sir. No,
All right.
sir.
Some of you may have, some of you may not have. 'Cause remember, we have different students from all across well, not the world. different students right across well, you know, in the Cornwall what do you call it? County. All right. So let me show you all right, you know what? Let me this type in thing here kind of rough. All right. So I would have to explain to you what a function is all them something, but this is actually the core math part of it. So to understand what are functions, I have to go into depth with some detailed analysis about relations, what a relation is, and all of that. But this is just the core math part of it. All right. So it says we're given two functions, f and g. All right. So it says calculate the value of f4. To calculate the value of f4 is very simple. All we need to do is locate which function is f4. Sorry, which function they're talking about. They're talking about the what? F function, which is this. So all we need to do is replace x in the f function with what? 4. So it becomes 2, which is this 2 here, and it says 2x. But because there's a 4 right there, we're going to replace x with what? 4. Or we input 4 into the function. Subtract 5. All right? Yeah, man. Let me tell you something, you know, some of you guys think about maths not relevant and wanna see, but let me tell you something. It's in manufacturing, they use a lot of mathematics. to run their machines, and they have to develop a mathematical formula or mathematical function to run the machine. And yeah, and let's say you have different parts and elements and ingredients you need to add, and everything is computerized. But however, before all of that, they have to sit down and work with a formula or a function or a flow chart. All right. So basically, 2 times 4 is just what? 8. Subtract 4. Sorry, not 4. That's 5. So 8 subtract 5, or 5 from 8 is 3. And that's it. Look, 1 mark. You guys see that?
Yes, sir.
All right, what you know?
Yes, sir.
So remember, this is a little crash course, right? So you're just learning something. That's why you're here, right? Learn something new, right? So what you know? So this is saying GF4. All right. It's kind of similar to part A, not true, but it have a next letter. All right. So we call this composite functions. Now, what is F4, class? F4 is what? We'll just work it out. F4 is what?
3. 3, sir.
3. All right. Now, what if this number was F like a different number? You'd have to work it out. But coincidentally, F4 is equal to 3. So what would we find? We work out the first one, F4, and F4 turns out to be what? 3. And then no, because it is equal to 3, then we find G of 3. So whatever answer F4 is, you replace the F4 with that answer, which is 3. And then the question now becomes what? G of 3. Are you following?
Yeah.
You want me to say it again?
Yes, sir.
Or you want me to say it again? Or are you following?
Sir, I'm gonna get the G part. Can
All
go
right.
again.
G. All right. Okay. So let me run it again. All right. So the question says to find GF of 4. Now to answer this question, we need to find what is what? F4. All right. Now, would you agree with me that if I find F4, what function is left back? G. Would you agree? Yes. So what is F4, by the way? F4 is 3 that we just work out. And we got 3 using the F function. So the answer is so the GF4 becomes G of 3. All right. Let me ask a question. Suppose when you work out F4, you get, say, 7. You'd have to put 7 right there, so don't you? Know what I'm saying? So whatever answer you get up here, so it goes right here, so. All right. Now, how we find G of 3? Which function we're going to use? The F function or the G function? We're going to have to use the G function. And this is the G function, right? So it says, so the G function is x squared plus 3. So we're going to replace x with what? With 3. So it's going to be 3 square plus 3. What is 3 square? 9. What's 9 plus 3?
12.
12. All right. And that's the answer. That's part B. So if you're writing down this and you haven't done this before, just write relations, functions, and graphs, or functions. And let me see if you guys remember what I was saying. What type of function is this called? Starts with a C.
Composition.
You think of English? Yado?
Composite.
Composition. Composition. All right.
We know
Composite.
it's a compo word, you know, so.
All right. So it's a composite function. To be frank with you, this is actually algebra. You know? This is not really functions. You know, this is pure algebra. All right, so it's 541. I will do one more of these questions, or we will do one more of these questions on call today. All right. Can I take this off now? Anybody writing?
No, sir.
All right. Let's look at the last part. Can somebody tell me what that means? Part 2 starts with I. It's the blank of F. If you have done matrices, you'll probably know. Right. So basically, how do you find the inverse, not of a matrix, but of a what? A function. So this is what you do. All right. So you identify that this is the F function, right? So to find the inverse, this is what you do. Is a procedure. You say, okay, let me write properly. Let y equal the function, which is what? 2x subtract 5. Everybody see that? I just use a random number variable here. So here it could be anything, but the books always say y. All right, so that's step number 1. I should probably write this up a little bit to the top. Whoops, hold off. That was eraser. Let me just write up a little bit to the top. So you say, okay, let y equals 2x subtract 5. All right, now the next step now, what are we doing, class? I'm teaching you guys how to find the what? The inverse of a function, not of a matrix, Inverse. All right. Next step, we're going to interchange x and y. You hear me say? Interchange x and y. In other words, which part y there, you put what? X. And where x is, where you think you do? You put y. All right? You follow? Yes. And then after that, we're going to find y, or make y the subject of the formula. Everybody following? You guys want me to say it again? All right. Now, how do we find y? Well, first of all, it's like an equation. So if I want y, I don't need that -5 there, not true? Would you agree? How would you get rid of -5? By adding 5 to the right and 5 to the what? Left. So we end up with x plus 5 equals 2y subtract 5 plus 5. And then what will happen here? That will go away, don't you? That gone. All right, go up here so now. All right. Tell us some soon, come here. All right, so we end up with x plus 5 x plus 5 equals what? 2y. All right. But what do we want to find? Y. So what I do here is just divide everything by 2. And this 2 cancel out. So that's the answer. So y is equal to x plus 5 or 2. Whatever y is equal to 2, whatever y is equal to, that would have been the what? The inverse. So that's the answer. So f inverse is equal to what? X plus 5 over 2. Any questions? All right. Anybody writing this off?
Yes, sir.
All right. I'm going to give you one to try. I'm going to give you, you have to hurry up though, you know. Tell me when I can take this down.
Okay, sir, you can go ahead.
All right. Anybody's writing? All right. Okay. I'm going to give you guys this to try. Don't be alarmed. You know, just give it a try, man. Just give it a try. You can do it. Just look back at the notes that you have, that you wrote down, and try it. Look how about it in.
Guys, before you go, please remember to click on the link on I'm only seeing 7 persons registered and we have 12 persons on the class. So just 3 things to click on. It doesn't even take 1 minute, about 20 seconds to do it. Just click on it and register for me, please.
Let's go talk to you. All right. Are we making progress? All right. I'm going to give you 2 more minutes to wrap up.
Sir, me lost, sir. You may wait for you. So just tell me when you're ready,
You lost?
What you mean, man? We don't even know if to start.
So what about the first example?
I never write down the instructions. Me only write like a question. Then me don't even understand.
Okay. All right. All right. In the interest of time, I say, can someone tell me what you think G3 mean? What do you think we're gonna do? What do you think? How do you think we're gonna work out G3? Look for G function, replace X with 3. All right. So the G function is X squared. So then therefore it's gonna be what? 3 squared. What is 3 squared? 9.
9.
Then no, it says to work out what? G negative 3. G negative 3. And G negative 3 is going to be same G function here. Is going to be negative 3 square. What is negative 3 square, class? It's still what? It's still 9. So this is actually 9 plus 9, which is 18. That's the answer.
Sir, that may have, sir, but I never know if you're right, sir.
Very good. Anybody's got 18? All right. Well, you're learning something, you know. All right. Let's look at 2 now. All right, tell you what, let's work out 3 first. Let us work out 3 first, right? I'm just trying to be consistent in the first question. All right, so part 3 says find FG2. Okay, so let me write. Right, let me just put a little thing right here. All right, so FG2. Let me see if anybody remember anything at all I said a while ago. How are you going to approach this question? what are we going to work out first?
G2.
Right, G2. All right. So we need to work out what? G2. All right. Now, in the previous question, part 1, we had to work out G2, but wait, notice. There's no G2 working out. So we're gonna have to just work, we don't have to just work out G2. So G2 where's the G function? Right there. See it? So we're gonna replace X with 2. So it's gonna be what? 2 square. What is 2 square, class?
4.
4.
4.
All right. Let me see if we really learn now. By the way, we're doing part 3 here. Part 3. What is the next step? How to find G2?
So we're going to find F.
Right. We're going to find F. But F what number? F4. Whatever,
F4.
right. Whatever number you get for G2. Right. So we're going to find F4. All right. Which function are we going to look at? Are we going to look at this G function here to work out the F4? Or the F function now?
F
Right.
function.
Makes sense. Right. So the F function says, let's say a half, where X is, we replace X with whatever value we have in the function. Plus 5. What's half of 4?
2.
2.
And 2 plus 5.
7.
7.
Yeah. Hey, you know, so them little math say, you know, half of 4. When time primary school children hear we're talking, and they say, well, I want to learn up 60. All right. So this is the answer for part 3. All right. Yeah, man, write it off, man. And meditate on it. All right. Okay. All right. So we're on to the last part of this now. We're on the home run of the boundary. All right. So we want to find F inverse what? 6. All right. Let me see if you guys remember anything with our teacher now. How do we find the inverse? Let me get a little hint. Let what?
Y.
Let Y or N.
Right. Let Y equal what now?
Half.
The function. Right, a half. All right, you know what? To make life easy for us, let's change a half to 0.5. Here. So let Y equals 0.5. X plus 5. Life is a bit easier for us. All right. All right. What's the next step, class?
You're going to interchange.
Right. Interchange X and Y. So where Y is, you put X. And where X is, you put Y. Plus 5. All right. And the next step is that I'm just going to hurry it up. We're going to find Y. All right. So to find Y, what we're going to do now, I don't need plus 5 because I need Y. So let's get rid of it. So we're going to subtract 5 on the right and also 5 on the left. So we end up with x subtract 5 equals 0.5 y. And the 5, you know, oh, I don't have enough space, you know. But this have been plus 5 subtract 5. So that will disappear here. So then no, what we do now, we just divide everything by what? 0.5.
0.5.
So that cancel out. So y is equal to x subtract 5 over, what is 0.5? A half, not sure. Yeah.
Yes, sir.
But guess what, you know? The two game automatically go upstairs. So we end up with 2 open bracket x minus 5. All right. So for example, if you have 3 divided by a half, what is that? That's actually 6. Is that? 2 divided by a half is actually 6. What happens is that the 2 just go up there, so shortcut 2, 3, 6. All right. Okay. All right. And please register here because I Mr. Green would have asked you to.
Sir, go back over the last 3 steps to me again, please.
All right. The last 3. Let me see. 1, 2. Starting here.
Fine Y.
Fine. Right. Okay. All right. Cool. No problem. All right. You know what? Let me. This place is
Because
cluttered up.
I simplify, me end up simplifying, you know, that's my mistake. Like, me not leave it as a fraction, like what would look like a fraction, this. That's a mistake. So I want to go back through that.
All right. What's I know? Which one would I know? All right. So let us. All right. I have some space right here. So I have. All right. Hold on. All right. Someone tell me the equation that we're solving.
The equation, let y equal 0.5 x plus that
X.
one,
It's x equal. X
it says let
equal.
y 0.5 y plus 5.
Right. So x. Right. So x equal. Okay, I catch it now. X equals 0.5 y plus 5. That's what we're trying to find y for this, not true?
Yes.
All right. Grant. That's how you go.
Yeah.
Yes, sir.
This part, right. So this part is what we're at. We want to find y because we did the let before. All right. Okay. So we need to find Oh, I want this. Okay. Same thing again. What's happening here? Oh, I see what's happening. All right. So basically, see, we want what? Y, right? So what we're going to do is, see, I don't need this because I this alone want. All right. Let us say y is the treasure, is the gold. We want the gold. So I need this alone. So I don't need plus 5. So to get rid of plus 5, what do? I subtract 5. But because you subtract 5 on the right, you have to do it also on the left, because all equations must be what? Balanced. Then no, all is gone. All right. So what we're left with now is x minus 5 equals 0.5. Why? All right, you following so far? Then
Yeah,
no,
yeah.
then no. Remember, no. Imagine that. All right, suppose you had 5y right there. So you divide everything by 5, find y. So it's like we have 0.5. So we divide everything. We divide everything by 0.5. All right. And what's gonna happen? That cancel. That cancel, not true. All right. So what we left back is what? Well, is y equal x minus 5 over what? 0.5. So we end up
Yeah,
with
yeah, I get it.
x minus,
Sir.
yes?
Sir, how we get to 0.5 again?
Oh, remember the half? I just convert the half to a decimal.
Okay, sir.
Yeah. But I want to make I didn't leave it like this. What I did was to say, you know something? This is actually what? 1 over 2. All right? And then no, this turns out to be f inverse x equal, what happens that 2 go upstairs now, it becomes what? 2 bracket x minus 5. All right. But let me show you something, guys. All right, hold on. Everybody following this part? You see we get the 2 beside here, so this 2 is this 2 here. So this would have been the answer. But guess what, man, class? In the first example that I showed you.
Sir, you two, which two?
No, what I'm saying, the x minus 5 divided by a half by 0.5, I convert it to a fraction right here, so. So it's actually x minus 5 divided by 1 over 2. But to simplify this, the 2 down here so goes straight to the top beside the x minus 5. So this would have been the answer. All right, let me show you. Let me show you. If you're not seeing it, suppose I say you have 5 suppose you have 5, right? 5 divided by, say, 2. No, let me use 1/3. All right, that's going to be 15 because the 3 is going to go upstairs. Let me show you how to get the 15. It's 5 divided by, let me just use this, by a third, right? That's what it means, right? 5 over 1/3 means 5 divided by 1/3. That's how you go. Yeah, man. And then what happens is that, how do we divide fractions, class? we change the division to what?
Multiplication.
Right. And what we do with the 1/3? We
Reciprocate.
right. So that becomes what? 3/1. Hence what? You get 15. Do you see it now? But you don't have to go through all of this. All you need to understand is that you get 3. You must multiply 3 down here so by the 5. But guess what? It only works if this is 1. Is it? If this is a 1, then you can actually do that. All right. So that's why the half becomes what? 2. All right. But I want to draw your attention to something before I go. In the first example, you notice that when I found the f inverse, you notice there was no number right here, so it's just f inverse x. What you notice in this question here? There's a number beside the 6 by the inverse. What do you think they want us to do with the 6? After you get the answer, you then replace x in the answer with what? With the 6. All right. So I know this. Right. I know this meeting has been recorded, so you can always look back. All right. So this becomes 2, and that's going to be 6. Subtract 5. All right, and that's 2, and well, that's 1, not true? So the answer is just what? 2. All right. All right. So I will see you next week. All right.
Okay, sir.
All right. Take it easy. Mr. Green, are you there?
Yeah, man. I hope
All right.
everybody registered. All right.
Yeah, man. Cool.
As soon as I post the video,
All right.